Good evening. Today we are going to see the NPTEL assignment number 7. So we have first calculate the static indeterminacy and kinematic indeterminacy of the following pin jointed structure. So we have ds E equal to R minus equilibrium equations. Now we have here 1, 2, 3, 4. So we have 4 reactions minus 3 equilibrium equation 1. Then we have dsi m minus 2j minus 3. Now m we have 1, 2, then we have 3, and then we have 4, 5, 6, 7, 8. So we have m that is equal to 8 minus. Now joints we have 1, 2, 3, 4, 5, 6. So we have 2 into 6 minus 3. So 8 minus 9, so minus 1. So this is determinate internally and externally indeterminate. So ds equal to dse plus dsi. But if value comes minus, it should not be considered. And therefore we have 1. Then this is considered as statically internally determinate. This is statically internally determinate. This is deficient, and then we will have this as 1. Now we have dk 2j minus r. Now j we have 6, minus reaction we have 4. So we have 12 minus 4 we have 8. So 1 and 8, and 1 and 8 we have option that is A. So we have option is A. Now second we have again static indeterminacy. So again we will have ds E equal to R minus equilibrium equations. Then we have here 2. Here also we have 2, 4. And then here we have 1, 5. So we have 5 minus 3, and that is 2. dsi is equal to m minus 2j minus 3. Now m we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 21. So we have 21 minus 2 into number of joints we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So we have 2 into 11 minus 3. And then we have 21 minus 19 equal to 2. And then we have ds equal to static indeterminacy 2 plus 2, that is 4. So we have answer 4, which is D, statically indeterminate to degree 4. Then we have third, find out kinematic indeterminacy and axially rigid means axial deformation neglected. Axial deformation neglected. And then we will calculate it. Now as axial deformation is not there, so we will go theta and then delta. So we have this will be theta 1. Here we have theta 2. First we will mark all theta, theta 3, theta 4, theta 5, theta 6, 7, 8, 9, and we have theta 10. Now delta we have here delta H1 1, then we have delta H2 2, then at this level delta H3, and at this level delta H4. So we have 10 theta and delta H we have at 4. And therefore we will get dk that is equal to 10 plus 4, and we have this value as 14. And if we will see, we have 14, that is C. So we have answer that is C. Now we will go to the fourth. Now find out the kinematic indeterminacy of the following frame. Again here axial deformation is not possible, so neglected. And then we have to again go with, so we have theta 1, then we have theta 2, we have theta 3, we have theta 4, we have theta 5. Now you can see here we have delta H1 horizontal displacement. Here we have delta H2. Now it can have vertical displacement which will be delta V1. So we have theta, if we will see, we have 5. We have delta H1 2 and then delta V1 we have 1. So total we have 8 and therefore we have dk that is equal to 8. So this is fourth where we have kinematic indeterminacy that is equal to 8. Now we will go to the next, determine the kinematic indeterminacy of the following beam. Members are assumed to be actually inextensible. So no horizontal displacement we have. Now we have theta 1, then we have theta 2. Here we have theta 3 on this side we have different theta 4. Here we have theta 5, theta 6. Here we have theta 7. No axial deformation, but it can deflect vertically. Then we have delta V1. Then here also we have vertical displacement at this, so which will be delta V2. And this also we have vertical displacement delta V3. So we have theta we have 7 and delta we have 3. So total we have 7 plus 3 and that is equal to 10. So we have option is A. So option A. So we have dk that is equal to 10. Now go to 6. Determine the static indeterminacy of the structure as shown in figure. So now we will go with for first. So we have how many reactions? We will have 1, so 2 and then we have 3. So go on this side, we have 1, then we have 2 and then we have 3. So we have ds E equal to R minus equilibrium equations. We have R 6 minus 3. So ds E we have that is equal to 3 for first structure. Now if we will go to the second, now here dsi if we will see, we have 0 as open loop structure. Open loop structure. Because in open loop structure, C is equal to 0 and we have formula for DSI 3C. So 3 into 0 equal to 0. Now go to second, we have 1, 2, 3, then 4 and 5. So we have ds E equal to R minus equilibrium equations 5 minus 3 and that is 2. Now dsi equal to 3c. Now how many cuts we require? So 1 and 2. So c equal to 2 to make structure open loop. To make a structure open loop. And therefore 3 into 2, so we have 6 and ds we have 2 plus 6 which is equal to 8 and therefore we have 3 and 8. Option is B, 3 and 8. Here we have ds equal to 3 plus 0 which is 3. So 3 and 8. So these are the questions which are from NPTEL assignment 7. So remaining questions we will see in the next video. So we will stop here only. Thank you.